this is how the circuit in Tinkercad looks like. Unfortunately, Tinkercad don't have a camera in it, but we can look at how the other components of the circuit work. We have connected the signal pin of servo to pin number 6 of Arduino. Then the echo pin of ultrasonic sensor is connected to pin number 12, and the trigger pin is connected to pin number 13 here. We provide the power to ultrasonic sensor and the servo from the Arduino board by taking the 5-volt supply from here. So what happens is that when the ultrasonic sensor detects the object in its vicinity, then the servo motor rotates. Then the servo motor observes the idle time of at least 5 seconds before turning on once again. We can adjust the idle time by just a small change in the code, and in a day the servo will rotate only thrice to dispense the food, which is also adjustable. Now let's start the simulation. Let's bring the object less than 15 centimeters. See, the servo motor rotated. Now it waits for 5 seconds and perform the second rotation, and then waits again for 5 seconds, and then it will perform the third rotation, and now it won't perform any more rotations. So yeah, 5 seconds has elapsed and no other rotation have.
Hello everyone, I'm Vedant and I'll go through the design of our CAD model. This is a very simple cat feeder that we have designed here, or a pet feeder. So it makes use of a servo motor for rotation that is connected right behind. This is the input for the servo motor, and here it is connected to a rotating flap which will allow the food to actually dispatch and get collected here for the pet as soon as the face is detected. So these are the inclined surfaces that I have designed right here. And now this is the food input for the model from where I can put in the food and it gets stored here, and as soon as the servo rotates to a certain angle, the food will be dispatched. So I'll just show the rotation of the servo. So it would be a manual rotation that we'll do right here. So as you can see, this is how I can rotate the servo and the food will finally be dispatched like this to certain degrees of motion. This helps us to understand the model in a better manner. And now I have made a closing flap so as to just protect this device as the food should come out in this container only. So this is a movable flap that I have designed. It can move up and down, as you can see. So I'll just close this device like this. So this is a simple representation of our model, and I have added labelings so as to make this entire model presentable. Thank you.
So now let's have a look at the code. The code basically have two parts, that is Arduino sketch and the Python script. So this is the Arduino script and we can open it by files, examples, then go to Firmata and then select standard Firmata. Firmata is a protocol for communicating with microcontrollers from software on a host computer. Standard Firmata is a general purpose sketch which we load upon our Arduino and then use our laptop to exclusively to interact with the Arduino board. This is our Python script which we use to interact with the Arduino board. These are the library we used in our code, followed by some global variables. We capture the video from our webcam. The webcam we use here is at the index 0. If we want to use some other webcam, then we can change the index accordingly. We use the har cascade frontal cat face.xml file to detect face. We take a look at the video frame by frame, and each frame is referred to as an image. We read the image from the cap variable here, and then if the value of read is false, that means a image is not read from the video, and then we continue the code. Then we look at the video frame by frame. For each frame we perform the following set of code. First of all we change the color of uh, image to black and white for the better working of the filter, and then using the multi-scale method we detect the face and store the data in a numpy array. After storing the data, we draw a rectangle on the boundary of a face so that we know that the face is detected on it, and then check the size of that numpy array. Then we see the distance detected by the ultrasonic sensor, and when the distance detected by the ultrasonic sensor is less than 15 and a face is detected simultaneously, then we give command to rotate the servo to 30 degrees.
Hello everyone, now I'll be explaining the basic working of our cat food dispenser. The working starts with the camera. For now I'll be using the webcam of our laptop. This camera will detect a cat, and then it will also sense this ultrasonic distance detector will also sense how far the cat is from the camera. Then we'll be using this Uno board, which will from the readings of the ultrasonic detector judge if the motor which is connected to the shaft of the dispenser from the back side, as you can see over here, to rotate, and then the food comes out from the shaft from this outlet. That's it. So now we'll be looking into the actual working of a cat food dispenser. First of all, I'll be pouring this food into the container. Here we go. Here. Okay. Now I'll be running this code on VS Code. Here, the code is running. Now, as you remember that I'll be using my computer's webcam, so I'll be first uploading the photo. I have pre-downloaded an image of a cat on my phone, and now I'll be showing this photo. So let us wait for the detector to detect. So now, as you can see, the detector has already detected the cat from my phone. Now let us see if the dispenser has dispensed the food. Okay. Here, so here's the dispenser. Yeah, so I guess it's working perfectly. So that's it from my side. Thank you.